Hello everyone, I'm Wilson. Today I will do this photo reference called bipolar electric to enable the photo electrochemical electrochemical synthesis sensing. This paper is with analytical chemistry and is published in February in journal category in analytical chemistry. It's ranking in top 5.5%, and its impact factor is 6.8. And this is my CV. I graduated from National Private University. And now I'm studying my master degree in National Taiwan Normal University. I'm in the Jiantian lab. My research focus on electrochemistry and chemical education. In brief introduction this device. This device is combined for electrochemical and electrochemical with two model biosensors. PEC mode provides precise electrical signals, and EC mode provides user-friendly react. In this study, target Crime 1 and 40 is detected. We can observe the intensity of photoelectrical signals and the color trend of electrochromic material to detect the target protein. So selecting the material is important. Electromaterial like polyethylene and nickel oxide tungsten trioxide has high coloring efficiency, and like the figure below, it shows first response time. The coloration and bridge time were both less than 2 seconds. And among this, polyethylene is stand out because it has high stability and conductivity, and it shows both color window under the applied potential. The figure shows 1 volt to 0 volt. The polyethylene color from blue become green and light green. And to see the clear electrochromic color need strong photo current output. To increase the photo current output, we add a ascorbic acid as an electrodonor. But the electrolyte environment, like ascorbic acid and xylene and pH value, will affect the stability of polyethylene, and it will affect the accuracy and reliability of the measurement. So in this study, using curved bipolar electrode CBPE, we can avoid interface between the reaction substance and expand the range of analytes. This device coupled EC detection and optical sensing in different electrostatic cells. So EC cell using 0.1 millimolarity sulfuric acid and optical sensing cell using 0.1 molarity phosphorus buffer silent in electrochemical electrochromic couple PEC-BPE is common to use before, but photoelectrochemical electrochromic couple CBPE is the first time. In this work, so a key scientific question is if PEC sensor can also achieve significant signal output similar to EC system. So the workflow is Gaussian BIF to obtain zinc oxide and put CPSE content data on the surface of zinc oxide to get heterojunction and add atomer on the CPSE content data zinc oxide. So driving anode is doing by an atomer CPSE content data zinc oxide and ITO. And the driving tensor is made by polyethylene and ITO. And using Raman spectrum to categorize the bond, the characteristic is shown in the spectrum and is plain SEM and cross-sectional SEM image shows polyethylene is attached on the ITO block. So that's the stage in electric. In the civil class, is test in one molarity sulfuric acid. It shows 3 pair of peak. It corresponds to the 3 oxidation state. And it shows good chemical activity and excellent electrical property of energy, like from 1 volt to 0 volt. Polyethylene was reduced, so the color change from blue to green. And SEM and TEM image shows the shape of this material, like VIF has cubic structure and zinc oxide with polymers and aggregate together. And CPSE content is a physical with 3 nanometer. And CPSE content can see in SDL image. They are tightly attached to the surface of the zinc oxide nanoparticle. And in SRT pattern and SPS, can see this CPSE content data transfer content cadmium, selenium, zinc, and oxygen acid. In the photocurrent test, we can see after modify the photocurrent increase about 13.9 times, and in UVB CRA spectrum, result is after modify is redshift. So can see the bottom wavelength absorption. And also proposed mechanism. The mechanism is transfer electron for electron and holes in this type 2 heterojunction. In this slide, compare 3 modes by switching CBPE and driving test electron and inducing reference electron, we can get the largest both potential difference and the largest photocurrent and the most stable. Improve the EC signal and PEC signal. And this device is using 3D printing technology. It uses cell phone as light source and use the cell phone camera as detector to detect the color change of polyethylene. So this device is portable. When quiet air bind to the atom, the static effect reduce electron transfer, which affect both the photocurrent and the color of polyethylene, like the EIS plot. After each step of multiplication, the impedance increase and photocurrent response and the color of polyethylene shows the Q1F concentration is related to photocurrent and the color of polyethylene. And this slide shows this device has high sensitivity and greater reliability. The PEC mode, the photocurrent is really decreased with the Q1F concentration. And EC mode, the color intensity is linearly increased with the Q1F concentration, and the LOD is shown below. In selectivity test, the first selectivity for Q1F, it can efficiently distinguish the interference with other transgenic proteins. And reducibility test shows in different devices the PEC and electrochromic RST is about 3 to about 4%. And stability test show after 7 days the PEC and EC signal remain over 90%. And test real sample. Real sample is mice and soils. In this table, you can see using PEC mode and titanium mode, the recovery is from 91 to 96, and the detect result is similar to using ELISA method. And this work is this works signal is more stable and the detection sense is more sensitivity than other signal mode or remedial method. So in conclusion, this type reference CBPE photoelectrochemical electrocooling sensor would achieve synchrotron dividal detection of the Q1MB protein. It can show reliable signal and easy to read color change at the same time, and we use cell phone to detect. So it is great portability. And Q2, the question is the sulfuric acid concentration is for CV and electrochromic detection were the same, which could make the data less comparable. And only the LOD was correct. The then show the LOQ. Question C, improvement. They could extend the stability test over longer period. And also simulate different pH values and salt environment. That can help better prove the device durability in real environment. This is reference. Thank you for your attention.